Now we will discuss extended ACL. In last session, we have completed standard ACL. Now we will discuss extended ACL. Extended ACL is used to control traffic based on source IP, destination IP, and port numbers. In extended ACL, we should specify source IP, destination IP, and port number. Extended ACL is always configured close to source. Close to source. It is opposite of standard ACL. The standard ACL is always configured close to destination. Here, close to source. Extended ACL number range is 100 to 191, 100 to 199. To configure extended ACL in router, so these are the requirements. The first we should know these four. If you want to implement any extended ACL, first we should know these four. Source IP, destination IP, protocol, and service. Protocols are nothing but IP, TCP, or UDP, and ICMP. Service is application, port numbers. This is syntax, access list, ACL number, any number you can use between 100 and 199, action, deny or permit, protocol, IP, or TCP, or UDP. If you want to block specific application, we will use TCP or UDP. Specific application means FTP, HTTP, HTTPS, DNS, TCP. Okay, if you want to block these kind of applications, the first we should know what is the transport layer of that application. For example, if you want to block FTP, FTP depends on TCP, right? FTP use TCP as transport protocol. So first here we should mention the TCP. If you want to block DNS, so what is DNS? DNS use UDP, right? So here we need to specify the UDP. If you want to block specific service, here we need to specify either TCP or UDP. But if you want to block complete communication, here we will specify IP. If you want to block only ping service, ping, we will use ICMP. So based on our requirement, we have to select protocols. So access list, ACL number, action, protocol, source IP, wildcard mask, destination IP, wildcard mask, and operator means equal or greater than or less than. That is operator. For example, if you want to block port number 80, if you use here greater than 80, router blocks 80, 81, 82, 83, 84, 85, 86. If you use less than 80, it blocks 80, 79, 78, 77, 76, 75 like that. If you use equal 80, router blocks only port number 80. Operators are this: greater than, less than, equal. Now we will implement ACL here. See, here my task is 192.168.2.2 user should not be able to access 192.168.3.100. I want to stop communication between these two IPs, 2.2 and 3.100. Complete communication. I don't want to stop communication from 2.2 to 3.2, 3.3, 3.4. Okay. If this user is trying to access this server, this user should not access. This extended ACL is always configured near to source, right? Near to source. Here, this is the source, right? So near to source means we have to implement this ACL in R2. And in R2, what is the inbound interface? What is the outbound interface? So R2 receive this traffic from this PC on F0 by 0 interface. So this is the inbound. R2 sends this traffic through this interface, right? To the server. So this is the outbound interface. Inbound and outbound. But extended ACL can be implemented in either in inbound interface or outbound interface. No problem. It works in both direction. Because here we are specifying both source IP, destination IP. So router takes action based on the source IP and destination IP. So now here, see here, task is 192.168.2.2 user should not be able to access 192.168.3.100. This is configuration. Access list, ACL number, you can use any number between 100 and 199. Action is DNA. Protocol is IP. Because I am going to stop complete communication. So protocol is IP. Host 192.160.2.0. Why host here? Because it's a single IP, not an entire network. And host 192.160.3.100. This is also single IP. And access list 100 permit IP any source, any destination. Interface F0 by 0. Oh, sorry, not okay, sorry. Yeah, this one. Interface F0 by 0. If you want to implement this ACL in inbound direction, interface F0 by 0, IP access group 100 in. If you want to implement this ACL in outbound direction, interface F1 by 0, IP access group 100 out. You can implement in any direction, either inbound direction or in outbound direction. Okay. See here, first I will implement in inbound direction. Okay. So copy these commands. Copy and paste in R2. Okay. So now check this communication. 2.2 to 3.100. See, destination host unreachable. I am getting from 192.168.2.1. Where is 2.1? 2.1 is gateway. This PC gateway, 2.2 gateway. When R2 receives this traffic, R2 simply drop that packet and sends response. Destination host unreachable message. And if you try to ping 3.2, see, it's pinging, right? Okay. Now I will remove this ACL in inbound interface. Okay, go to F0 by 0 interface. See here, I am already in interface, right? So interface. So just no IP access group 100 in. I removed this ACL from inbound interface. Now try to access 3.100. Okay, see, now it's pinging again. Now I will implement this ACL in outbound direction. Okay, F1 by 0. F1 by 0. Okay, interface F1 by 0. IP access group 100 out. Okay, so now try. See, again block. So extended ACL can be implemented either inbound interface or outbound interface. But there is a difference between inbound interface and outbound interface. There is a lot of difference. But internally, I will explain that later. Okay. So this is how to stop communication between 2 IPs.